Why is everyone suddenly talking about MCP, and why should Microsoft people care? Because the AI integration story you've been selling internally is collapsing under its own weight. Models can write decent plans. They can even sound confident while doing it. But enterprises don't pay for confidence. They pay for controlled outcomes. Here's the comfortable assumption. MCP is plugins for LLMs. A nicer way to bolt tools onto chat. That's the story because it feels familiar. It sounds like what we already did with add-ins, connectors, and yet another SDK. It is not. MCP is not a plugin system. It's not an API wrapper. It's not function calling, but standardized. Those descriptions are how you end up rebuilding the same glue code just with a new logo on it. This is the uncomfortable truth. MCP is where authority stops. In architectural terms, MCP is a protocol that sits between an AI host and the systems you actually care about. Graph, SharePoint, line of business APIs, anything with blast radius. And the point of that protocol isn't convenience. The point is to create a choke point where you can enforce identity, scope, audit, and failure behavior without trusting the model to behave, because the model will not behave. Not because it's evil, because it's probabilistic. It picks the next token, then the next token, and somewhere inside that it decides which tool to call and with what inputs. That's fine when the worst outcome is a wrong sentence. It's catastrophic when the outcome is create a user, share a file, delete a record, or exfiltrate a report. So the real problem MCP solves isn't model intelligence. It's bounded action at enterprise scale. Before MCP, every team built their own bridge. A bespoke wrapper around Graph, a custom connector to SharePoint, a hand-rolled middleware service with a service principal that never gets rotated because it's temporary. Meanwhile, policy drift happens, endpoints change, someone adds a permission just for this sprint, and now your integration becomes a permanent incident generator. And Microsoft environments amplify this because identity is the control plane. Entra decides what is possible. Conditional access decides what is survivable. Audit decides what is defensible when something goes wrong. So in this episode, the goal isn't to celebrate MCP. The goal is to make it obvious. We're going to build MCP from first principles, then place it inside a Microsoft native architecture. Entra on behalf of for delegated authority, managed identity for operational baselines, and service principal plus Azure API Management for the part everyone forgets, governance at the edge. And there's one claim I'm going to prove later. With real Entra flows, MCP isn't AI tooling, it's an integration security boundary masquerading as developer ergonomics. The foundational misunderstanding: LLMs don't touch APIs. Most teams start with the wrong mental model. They think the LLM is calling Graph, or hitting SharePoint, or running an API. And then they build a security story on top of that assumption. That assumption is false. The model never touches your API. It never sees your open API spec in the way a developer does. It never understands your error codes, your pagination rules, or your permissions model the way your integration code does. The model interacts with one thing: the text and structured tool descriptions you choose to put in front of it. That distinction matters because you are not securing an API call. You are securing a decision pipeline. Okay, so basically an agentic loop looks like this. You give the model a prompt plus a list of available tools. The model chooses a tool. Some host process executes the tool. The results come back. The model sees the results, then it decides what to do next. Repeat until it stops. Notice what's missing. There's no direct binding between the user asked a question and the API call is safe. The binding is mediated by tool descriptions, schemas, and host behavior. And that's why just call the API is not a plan. It's a shortcut around the part that actually fails in production. Here's what most people miss. In an enterprise, tool calling is not a coding problem. It's a context shaping problem. If the tool schema is vague, the model will fill in gaps. If the tool names overlap, the model will guess. If you allow optional parameters that change meaning, the model will improvise. If your output isn't stable, the model will learn the wrong patterns. And if you fix it later, you've already shipped a probabilistic interface into a deterministic environment. That's the collision APIs assume deterministic callers. LLMs are probabilistic callers, so the real failure mode isn't that the model can't do the task. The failure mode is ambiguity. Ambiguity in naming, ambiguity in inputs, ambiguity in outputs, ambiguity in what authority is being exercised when the tool runs. And it gets worse over time because the tool surface drifts. Someone adds a new parameter. Another team wraps the same backend with a slightly different tool. A third team adds a search tool that returns a different shape. Now, the model isn't choosing between one correct action and one incorrect action. It's choosing between three nearly correct actions that all work sometimes. Congratulations, you've built conditional chaos. This is also why prompt injection becomes a real operational concern. The model is not defending your API. The host is. The host decides what tools are available, what schemas are valid, what tokens are presented, and what failures are allowed to proceed. If your system lets untrusted content influence tool selection or tool inputs, it doesn't matter how secure your API is. You just move the attack surface upstream. The attacker isn't bypassing auth. They're steering the caller. So when someone says, we'll just give Copilot a service principal and let it call graph, what they're really doing is bypassing the only place where policy can be enforced consistently, the orchestration boundary. That boundary is what MCP standardizes, not the intelligence, the plumbing around authority. Once you see that, MCP stops sounding like plugins. It starts sounding like what it actually is, a way to describe capabilities precisely, invoke them consistently, and keep the model on the far side of a control plane you can audit and constrain. And now we can talk about the real cost of doing it the old way, because every bespoke bridge you build becomes an entropy generator. The Entropy Tax, custom AI glue as a permanent incident generator. Here's the part nobody budgets for. Once you let AI glue into the enterprise, you're not building an integration. You're adopting a new kind of maintenance burden, one that grows on its own. Because glue code doesn't stay glue, it becomes policy. It starts innocently. A team wants an agent, to read a SharePoint library, summarize a document set, and maybe create a planner task. So someone writes a thin wrapper around graph. They add a service principal. They store the secret in Key Vault. They ship. Everyone claps. And then reality shows up. The first failure mode is tool sprawl. Multiple teams will build the same bridge in parallel because there's no shared contract layer. One wrapper calls graph search. Another wrapper calls SharePoint REST. A third wrapper scrapes results from the graph drive endpoint because it was faster. Now you don't have one integration. You have three inconsistent interpretations of the same system, each with its own permissions, error handling, and logging. That's not innovation, that's fragmentation. The second failure mode is humans acting as transport. If you've ever watched someone use Copilot by copy-pasting an email thread into a prompt, then copy-pasting a response into Teams, you've seen the architecture. It's manual ETL with vibes. It works right up until it becomes a process, and then it becomes an audit problem. You can't prove what data was used. You can't prove what the model saw. You can't prove what was sent out. And you definitely can't prove the user had authority to move that data in the first place. The third failure mode is security debt that masquerades as velocity. This is where entropy becomes measurable. You add temporary app permissions. You grant sites, read, all because scoping is annoying. You add mail don't read to help with summarization. You keep a long-lived credential because rotating it breaks the tool. Over time, exceptions pile up. These exceptions are not edge cases, they are entropy generators. Because every exception weakens your ability to reason about the system. You no longer know which identities can touch which data, through which paths, under which conditions. You have transformed a deterministic security model into a probabilistic one. The fourth failure mode is drift. APIs change. Graph endpoints evolve. Permission semantics shift. Conditional access policies tighten. SharePoint inheritance gets fixed by someone who doesn't understand the business impact. Your glue code is now stale, but it doesn't fail loudly. It fails weirdly. Partial results, empty arrays, works for me access, tool outputs that look valid but aren't. And this is the worst kind of failure for an LLM-driven loop, because the model will treat ambiguity as a suggestion. If the tool returns a 403, the model might try a different tool. If the tool returns an empty response, the model might assume no data exists. If the tool returns a truncated payload, the model will fill the gap. Not maliciously, automatically. So custom glue becomes a permanent incident generator even when the code is correct because the environment it depends on is not static, it's alive. Policy changes, data changes, identity posture changes, and the more AI capabilities you bolt on, the more pathways you create for silent failure. This is why enterprises don't actually struggle with AI reasoning. They struggle with orchestration entropy. And the uncomfortable part is this. Every new team that just needs one tool makes the entropy worse for everyone else. Because now you have more identities, more secrets, more permissions, more wrappers, more logging formats, more exception handling styles, and more undocumented behavior. MCP doesn't magically make systems safe. It gives you a place to stop the spread. A standard contract boundary, a predictable capability surface, a single choke point where identity, scope, audit, and rate control can be enforced consistently. Without that choke point, you don't get a platform. You get 1,000 slightly different bridges, all quietly rotting, all still holding production traffic. Pre-MCP pattern 1. REST everywhere, context nowhere. The first pattern everyone tried was the obvious one. Just expose REST endpoints and call it a day. And yes, REST is fine. It's been fine for 20 years. It's predictable, cacheable, debuggable, and it makes developers feel like they're doing real engineering instead of arguing about prompt phrasing. But REST was designed for deterministic clients. An LLM is not one. REST assumes the caller already knows which endpoint to hit, what parameters mean, what shape comes back, and what to do when it doesn't. REST assumes the caller has a stable mental model of the API surface and enough discipline to follow it. The model has none of that discipline. It has pattern matching. So what happens in practice is that you don't actually give the model your REST API. You give it a description of your REST API. in the prompt, or through tool metadata, or through some internal tool router layer that translates natural language intent into HTTP calls. And this is where the arrow starts, because the moment you do that, pagination becomes a reasoning problem. Error handling becomes a reasoning problem. Idempotency becomes a reasoning problem. Filtering becomes a reasoning problem. And the model is now doing probabilistic inference over details that were never meant to be inferred. Here's the weird part. Even when you have an open API spec, you're still not safe. Open API is a contract for developers and code generators. It's great for documenting endpoints, schemas, auth schemes, and response types. But it doesn't solve capability negotiation. It doesn't solve tool discovery in a multi-tool world. And it definitely doesn't solve which of these 5 nearly identical endpoints should I call right now. In other words, OpenAPI can describe a surface. It can't enforce a decision boundary. So teams build wrappers. One wrapper for graph search, another wrapper for SharePoint lists, another wrapper for the one endpoint that returns less data so it's faster. Each wrapper has slightly different defaults, slightly different filtering, slightly different error mapping, slightly different logging. And now you don't have REST. You have interpretations of REST. That distinction matters because interpretations drift independently. The backend might evolve cleanly, but the wrappers don't. They get patched. They get copied. They get forked, and over time, your API integration becomes a zoo of nearly correct callers with different assumptions. And then the LLM arrives. Now the model is asked to choose between those wrappers. It doesn't know your intent. It doesn't know which wrapper is the blessed one. It only sees names, descriptions, and whatever examples you happen to include in the context. So if you have 3 tools called Search, Search Graph, and Search SharePoint, you're not giving the model capability. You're giving it ambiguity, and ambiguity becomes behavior. This is also where security starts to degrade in ways that look harmless. REST APIs often have broad permissions because developers want flexibility. But when you expose that same breadth to a model-driven caller, you're effectively saying, here's a loaded interface, please choose responsibly. It won't. Even worse, REST normalizes the idea that if one call fails, you just try another endpoint. That's acceptable in code where retries are bounded and logic is explicit. In an agent loop, retries are creative. The model will attempt different calls, different parameters, different scopes of search until it gets something that looks like progress. That's not resilience, that's wandering. So the REST everywhere pattern collapses because it externalizes context management. You push all the meaning into prompts and tool descriptions, and then you act surprised when the caller behaves inconsistently. This is why the industry pivoted to plugins next. Not because REST was broken, but because REST had no opinion about context, contracts, or governance at the AI boundary. Pre-MCP pattern 2, plugins and extensions as vendor gravity. So after REST failed to give models a stable, governable tool surface, the industry did what it always does. It built plugins. Plugins feel like progress because they move the integration problem into a product shape, a marketplace, a manifest, an install button, and a permission prompt. Everyone recognizes that pattern. Microsoft people especially. Add-ins, connectors, Teams apps, Power Platform connectors, same movie, new cast. But here's the foundational mistake. Most plugin ecosystems don't exist to reduce your integration debt. They exist to concentrate it. Vendor gravity is what happens when the platform becomes the default integration runtime. Your tools aren't yours anymore. They're artifacts shaped around a vendor's permission model, their audit model, their schema conventions, and their release cadence. That sounds manageable until you realize you just outsourced your boundary decisions to someone else's roadmap. And enterprises don't fail because they lack features. They fail because boundaries erode. Plugin systems typically start with an optimistic premise. We'll let the model call tools, but safely. So the platform defines a plugin schema. You register an endpoint, you describe actions, and the host decides when to call them. It looks clean. It demos well. Then you scale it. Now the real issues show up. Inconsistent permissions, inconsistent schemas, and inconsistent auditing. One plugin asks for broad read access because it can't function otherwise. Another uses fine-grained scopes but returns messy, untyped output. A third logs nothing useful because the platform doesn't enforce audit discipline at the tool boundary. So you end up with an ecosystem of integrations that are all technically supported but operationally incomparable. That is not interoperability, that is standardization theater. The second problem is maintenance reality. In a plugin ecosystem, every platform update is a revalidation event. The host changes how it interprets tool descriptions. The model changes how it selects tools. The platform changes permission prompts or deprecates an auth flow or modifies how it passes context. Your plugin still works until it doesn't. And when it breaks at the worst layer, the layer where an LLM decides what to do next. That means your incident isn't API call failed. Your incident is agent behavior drifted. And you can't patch that with a hotfix and a postman test. The third problem is lock-in, and it's more subtle than we used proprietary APIs. Lock-in happens because you build against the platform's integration contract, not your own. Tool naming conventions, parameter shapes, error mapping, rate limits, approval prompts, and user interaction patterns become entangled with one vendor's client. So if you ever want to move the tool to another host, another Copilot surface, another IDE agent, another model provider, you're not porting code. You're rebuilding semantics. And semantics are where the real cost is. This is also where governance gets weird. Enterprises want one consistent enforcement plane: identity, policy, logging, throttling, retention. Plugin ecosystems usually give you some of that, but in platform-shaped ways. You get the platform's consent screen, the platform's audit format, the platform's throttling assumptions. And when you need to answer a compliance question, who accessed what, under what user, through which tool, with what input, you discover that your data is trapped inside the platform's lens. It's auditable, but only in the way the vendor thinks matters. So plugins solved one pain, distribution, and replaced it with a bigger one. Your integration boundary became a product feature you don't control, which is why everyone got excited about function calling next. It looked like the escape hatch. Forget marketplaces, forget vendor schemas, just define functions in code, call them with structured arguments, keep it inside your app. And then scale arrived. Pre-MCP pattern 3, function calling without a protocol. Function calling looked like the grown-up version of plugins. No marketplace, no vendor manifest format, no install this extension. Just a set of functions in your own codebase, described with JSON schema and invoked by the model with structured arguments, clean, familiar, contained. And for a single app in a single repo with a single team, it mostly works. But here's what function calling actually is. It's a local convention inside one client. It is not a protocol. A protocol is what lets independent systems coordinate without sharing a code base, a deployment pipeline, or a set of assumptions. HTTP is a protocol. OAuth is a protocol. They survive because they define the interaction boundary clearly enough that two strangers can interoperate and still argue about everything else. Function calling doesn't do that. Function calling says, inside this one application, we'll give the model a list of callable things. It does not standardize. Discovery across environments, version negotiation, transports, isolation, governance, or audit semantics. And those missing layers are exactly where enterprises bleed. So what happens? Everyone invents them again. One team puts functions behind an internal gateway. Another team wraps them with a thin tool router. A third team adds a database-backed registry so tools can be enabled per tenant. Someone else adds policy checks before execution. And now you've rebuilt a platform. Poorly, in 5 different ways, with 5 different security failure modes. This is the part most people don't want to hear. Function calling is not a boundary. It's a convenience layer. The model still doesn't touch your API. The model still only sees descriptions. And if your descriptions are incomplete, the model still improvises. You just move the surface from REST endpoints to function names. And then you hit the overlap problem. In the real world, every enterprise has 3 search functions. One searches graph, one searches SharePoint, one searches the app database. Each one returns a different shape. Each one has different paging, different throttling, different semantics for top. The model sees 3 tools that look like they do the same thing, and it chooses based on vibes and token probabilities. That's not tool use, that's tool roulette. So teams try to fix it by stuffing more explanation into the tool description. Longer prompts, more examples, more rules. And it works until the next team adds the 4th search function. Because the root cause isn't documentation quality. The root cause is that you never established a governable contract boundary. There's also a security trap hidden here. With function calling, teams often assume that because the function is in the app, it inherits the app's security posture. But the function is typically executed by the server-side runtime identity, not the user, not the requester, the runtime. So you end up with a quiet privilege escalation. User asks a question, model requests a function, server executes it with whatever identity the service is running under. If that identity is a service principal with broad graph permissions, because it was easier, then your AI helper is now an unbounded automation account with a chat interface. That is not a good time. And even if you do the right thing and thread user tokens through, you still don't have the protocol level enforcement and telemetry you need. You don't have standardized call envelopes. You don't have consistent correlation IDs across tool calls. You don't have portable audit events. You don't have a clean way to say, this tool requires delegated access and this other tool requires app-only access, and the host must enforce that distinction. Instead, you rely on developer discipline, which is just entropy with a nicer commit history. Function calling was the escape hatch from plugin lock-in. But at enterprise scale, it just created a new kind of sprawl, private tool APIs that can't interoperate, can't be governed consistently, and can't be shared across hosts without rewriting everything again. And that's why the next step wasn't a better function calling library, it was a protocol. Pre-MCP pattern 4. Agent frameworks aren't standards. After function calling hit its limits, the next move was predictable. Frameworks. LangChain, semantic kernel, autogen, langgraph. Then a new one every week, each promising the same thing. Stop writing glue, start building agents. Frameworks do help. They give you patterns for tool selection, memory, retrieves, planning, and orchestration. They make prototypes feel like products for about 2 weeks. And then the enterprise shows up. Here's the foundational mistake. Frameworks optimize developer velocity inside a project. Standards optimize interoperability across projects. Those are not the same job. A framework is a set of conventions plus runtime code. It assumes you'll run its loop, store state its way, define tools its way, and deploy it in a world where you control both ends. That's fine when you own the whole stack. Enterprises don't own the whole stack. They have multiple teams, multiple languages, multiple hosting environments, multiple risk postures, and multiple approval chains that exist because auditors don't accept the framework handles it as an answer. So portability collapses first. Tools written for one framework don't transfer cleanly to another, even when they look similar. One framework calls tools with a certain schema shape. Another embeds extra metadata. A third models tools as a class with side effects. A fourth assumes a specific message format for streaming. The details vary, and those details are where systems break. You end up with the same problem you had with plugins, just redistributed, integration artifacts tied to a runtime you didn't want to standardize on. Then governance collapses. Most frameworks can log, they can trace, they can do observability, but they don't give you audit-grade boundaries by default because audit-grade boundaries are not a library feature. They're an architectural decision enforced at the edges, identity proof, policy evaluation, data minimization, and a clear mapping from action to accountable principle. If your agent framework executes tools using an application identity with broad permissions, you didn't build an agent. You built a privileged automation account with conversational UX. If your framework allows a tool to receive arbitrary user-provided strings that flow straight into downstream APIs, you didn't build orchestration. You built a prompt injection amplifier. And frameworks tend to hide the sharp edges because they're trying to be helpful. Helpful means convenience defaults. Convenience defaults mean silent permission expansion, implicit retries, broad tool exposure, and just make it work behavior. That's how entropy enters. There's also a lifecycle problem that frameworks can't solve for you. Enterprises don't just need agents to run, they need them to survive. Durable executions, timeouts, compensating actions, fail-closed behavior, human approvals, cost controls, change management, a stable contract that other teams can build against without importing your entire runtime. Frameworks are not built to be that contract, they are built to be your scaffolding. So what happens over time is simple. Every team picks a different framework, then every team builds a different tool abstraction, then every team invents a different way to secure it. Then security teams show up and ban half of it because there's no consistent enforcement point. And now you're back to the beginning, custom glue everywhere. This is the uncomfortable truth. Agent frameworks are accelerators for prototypes. They are not coordination layers for ecosystems. And once you accept that, the next step becomes inevitable. The missing layer isn't a better agent loop. The missing layer is a protocol that defines how tools are described, how capabilities are discovered, how calls are transported, and where isolation boundaries live. That's what MCP is trying to be. Why a protocol was inevitable. Standards beat frameworks at scale. Once you've watched REST wrappers drift, plugin ecosystems trap you, function calling fragment into private conventions, and agent frameworks multiply like rabbits, you end up with one conclusion. The problem isn't that teams can't build integrations. The problem is that they can't coordinate them. Coordination is not a library feature. It's a protocol problem. This is why protocols keep showing up at the exact moment an ecosystem stops being a project and starts being an economy. HTTP didn't win because it was the most elegant way to move bytes. It won because it let strangers build software that could talk to other software without a shared code base. OAuth didn't win because developers love auth flows. It won because it let independent systems delegate authority without exchanging passwords and without inventing a new custom trust dance every time. OpenAPI exists for the same reason, not because APIs were impossible, but because organizations needed a shared contract language to reduce ambiguity across teams, vendors, and tooling. MCP is the same move, just aimed at a newer failure mode, because the moment you put an LLM in the loop, you introduce a caller that is inherently non-deterministic, operating against systems that are designed to be deterministic. The integration problem stops being how do we call the API and becomes how do we express capabilities and authority in a way that stays stable even when the caller is probabilistic. Frameworks can't solve that. They can only hide it. Standards don't hide complexity. They pin it down. That distinction matters. A framework says, here's how we do tool calling in this runtime. A standard says, here's how any runtime can describe tools, negotiate capabilities, and invoke them over a consistent envelope. That's the difference between an integration that works in one repo and an integration that can become an organizational asset. And in an enterprise, organizational assets are the only thing worth building. Everything else becomes abandoned middleware with a service principle nobody owns. Here's the other uncomfortable truth. Once multiple tool providers and multiple tool consumers exist, best practice collapses. It always does. Best practice requires alignment. Alignment requires governance. Governance requires a shared boundary. Without a shared boundary, your best practice is just a style guide no one reads. So a protocol becomes inevitable because it gives you three things frameworks can't provide across an ecosystem. First, a stable interaction contract. Not we call functions, but how you list capabilities, how you call them, what the request and response envelopes look like, how errors are represented, and how state is managed when state matters. Second, portability. A tool described through a protocol can outlive your current agent framework. It can outlive your current model provider. It can outlive your current host application. That's not theoretical. That's the difference between a 2-year investment and a quarterly experiment. Third, a place to enforce boundaries consistently. Not by trusting developers to remember rules, but by forcing the interaction through a shape where identity, policy, and audit can attach. And this is why MCP's bet is not, let's standardize AI integrations. It's narrower and smarter. Standardize how context and capabilities are presented to a model-driven host and how the host invokes external tool servers in a controlled way. That's why MCP isn't competing with agent frameworks. It's sitting underneath them. Frameworks can keep innovating on planning loops and memory strategies and orchestration patterns. Fine, let them. But they need a stable substrate for tool integration that doesn't turn into glue code entropy the moment you cross team boundaries. This is also why this fits Microsoft's world so well. Microsoft doesn't sell simple. Microsoft sells governable. Identity first, policy-driven, audit-heavy systems that assume entropy is the default and control has to be enforced by design. So yes, a protocol was inevitable because at scale, you either standardize the boundary or you standardize the incident review. MCP defined precisely communication plus capabilities plus boundaries. So now define MCP without the analogies because USB for AI is cute, but it hides the part that matters. MCP is a protocol that defines how an AI host talks to external capability servers. That's it. Not the model talks to tools. The model still doesn't touch anything. The host does. MCP defines the shape of that interaction so it can be repeatable, inspectable, and governable. At the wire level, MCP uses JSON RPC2 as the message format. That means you get a predictable request and response envelope. Method names, parameters, IDs, and structured error objects. The point isn't that JSON RPC is fashionable. The point is that the tool call stops being some HTTP request your agent loop invented and becomes a standardized call with a known lifecycle. MCP also forces you to separate two layers people keep mixing up: transport and protocol. The protocol is the message format and semantics. The transport is how bytes move. MCP supports local process boundary transports like STDIO and remote transports over HTTP with streaming options. Those transports aren't cosmetic. They define where your trust boundary sits. Local STDIO is a local execution trust problem. Remote HTTP is an identity and policy problem. Same protocol, different blast radius. Now the second part, capabilities. MCP is not, here's an endpoint, good luck. It's capability declaration. An MCP server advertises what it can do and the client negotiates what it supports. That means the host can enumerate tools and decide what to expose to the model and under what conditions. This matters because tool sprawl doesn't become manageable by writing better prompts. It becomes manageable when the host can treat tools as a capability surface, discoverable, versionable, and constrained, not a pile of bespoke function calls scattered across repos. In MCP, servers expose three primitives: tools, resources, and prompts. Tools are actions. They have names, descriptions, and schemas. They are the part that changes the world, or at least queries it with intent. Because the model is probabilistic, tools have to be deterministic. Your tool schema is you forcing ambiguity out of the interface. If you leave ambiguity in, the model will reintroduce it for you. Resources are raw context. Think read-oriented inputs that can be pulled into the model's working set or used for retrieval. They're not actions, they are structured ways to fetch data. And separating resources from tools is not pedantry. It's how you separate knowledge from authority. Prompts are templates. They're productized intent shaping. In practice, they're how a host can offer a consistent entry point like a / command without requiring every user to reinvent the same instruction set. Prompts aren't governance by themselves, but they reduce drift in how people ask for the same operation. Now the third part, boundaries. MCP's isolation model is the thing you should care about most. An MCP server does not automatically see the full conversation. The host mediates what context is sent. Each server is isolated from other servers. That means MCP gives you a place to implement data minimization by design. Only send the minimum context necessary for this call to this server at this time. That is the architectural choke point. It's the difference between the model can do things and the model can request things, and the platform decides what actually happens. So when people describe MCP as standardized function calling, they're missing the enforcement potential. Function calling is usually an in-process feature. MCP is an externalized contract with explicit discovery, explicit capability, capability surfaces, and transport choices that map cleanly to trust boundaries. And the cleanest way to say it is this. MCP is a protocol that turns tool use into an auditable, governable interface, because it puts the host back in charge of authority. That's what we needed all along. Now that MCP is defined precisely, the next step is to break down the primitives that actually matter in real systems, resources, tools, and prompts, and why mixing them is how you accidentally give an LLM more power than you intended. MCP primitives that actually matter: resources, tools, prompts. Most explanations of MCP stop at the vocabulary list, resources, tools, prompts, and then they move on, like naming the parts is the same as understanding the failure modes. It isn't. These three primitives are MCP's real contribution because they force you to separate things enterprises keep mixing together: information, action, and intent shaping. And when you mix them, you don't just create messy integrations. You create authority leaks. Start with resources. Resources are read-oriented. They are how an MCP server exposes context without pretending it's an action. Think of them as controlled retrieval surfaces. Give me the policy text. Give me the schema. Give me the metadata. Give me the last 20 entries. They're RAG-friendly by design because they produce inputs the host can decide to pass into the model's context window. But here's the crucial part. Resources should not mutate anything. The moment you let a resource also perform an action, you've created a hidden side effect channel. Side effects are where audit trails get fuzzy and blame gets shared. Enterprises don't survive shared blame. So you treat resources as context supply, stable shapes, clear identifiers, minimal surprise. If you want a model to understand what confidential means in your tenant, you don't give it a tool called interpret confidentiality. You give it a resource that returns the actual classification policy. Deterministic input, probabilistic reasoning, that's the correct separation. Now tools. Tools are where the blast radius lives. A tool is an action interface. It either changes the world or it queries something in a way that drives downstream action. And because the model is probabilistic, tool interfaces must be intentionally boring. Strict schemas, stable output shapes, narrow parameter ranges, and names that make overlap impossible. This is where most teams sabotage themselves. They define tools like search, get, update, and create with optional parameters that change meaning. Then they wonder why the model calls the wrong thing or calls the right thing with the wrong scope. The tool schema is not documentation. It is your enforcement mechanism against ambiguity. If you allow site ID or site URL as optional fields, the model will sometimes send both. If you allow query as a free string, the model will eventually embed instructions in it. If you return results as an untyped array of mixed objects, you're making the model reverse engineer your domain model mid-flight. That's not intelligence, that's punishment. The correct pattern is to design tools like deterministic RPC calls. Constrain inputs so a model can't get creative. Constrain outputs so a model can't hallucinate structure that isn't there. And log every call as a first-class audit event tied to an identity, a scope, and a correlation ID. Now prompts in MCP are templates, productized intent shaping. They exist because humans are the original entropy source. If you let every user invent their own "please summarize this and then do the thing" instruction set, you get behavioral drift. And drift turns into inconsistent tool usage, inconsistent approvals, and inconsistent risk. Prompts reduce that. They give the host a stable entry point. Use the approved template for SharePoint document review. Not because prompts are magic, but because they standardize how the task is framed and what constraints are stated. But prompts are not governance. They're guardrails for the human, not the model. The governance still lives in the host's decision about which resources and tools are even available and under which identity. So the split matters. Resources feed knowledge, tools exercise authority, prompts shape intent. Knowledge is not authority. Authority is not intent. And MCP's primitives force you to stop pretending they are. Next, the uncomfortable part, transport and state. Because when you move from local STDIO to remote HTTP, you're not changing performance characteristics. You're changing who has to be trusted. Transport and state, STDIO versus HTTP, local versus remote, and why it's not cosmetic. Transport is where most protocol people lose the room because it sounds like plumbing. But transport is not plumbing. Transport is the first place your trust model becomes real. MCP gives you at least two common transports, STDIO and HTTP. People talk about them like the difference is performance. Local is faster, remote is slower. Pick your favorite. That's the comfortable story. The real story is STDIO and HTTP change who you have to trust, what identity you can prove, and what failure looks like. Start with STDIO.stdio is a local process boundary. The host starts the MCP server as a child process, then communicates over standard input and output. No network, no load balancer, no TLS. It feels safe because it's on the machine. And it can be safe if you treat local execution as a security boundary, but most teams don't. They treat local as trusted. Then they start running random community MCP servers because it's convenient. And now your AI host is launching arbitrary code with whatever file system and network access your user account has. Local doesn't mean safe. Local means the trust decision moved from the network to the endpoint. If you're on Windows, that endpoint is now a workstation with browser sessions, cached tokens, synced OneDrive content, and usually an overprivileged developer identity. If you're on a build agent, it's worse. It's a machine with CI secrets and deployment permissions. So STDIO is great for development because it's simple and fast, and the isolation is basically the OS process boundary. But it also means the server is inside your blast radius. Now, HTTP is where the enterprise story begins, because remote MCP servers are how you build shared capability services. The SharePoint MCP server, the Graph MCP server, the ticketing MCP server, centralized, managed, logged, rate-limited, scalable. But remote means every tool call is now a distributed system call, so identity must be explicit. If your MCP server is remote and it doesn't authenticate callers properly, you didn't build a tool server, you built shadow IT with a JSON RPC wrapper. This is where Entra flows matter. With HTTP, you can and should require a token. That token should have an audience, scopes or roles, and an accountable principal. And you need to decide whether that principal is the user, the workload, or a brokered identity via on behalf of, because remote changes what the audit trail can prove. With STDIO, your audit trail is mostly host local. The user ran this tool. With HTTP, your audit trail can be centralized. This user, through this host, called this tool under this policy at this time. That's a different class of defensibility. Now, state MCP connections are typically stateful at the protocol level. That doesn't mean the server stores your conversation history. It means there's a session lifecycle. Initialize, negotiate capabilities, exchange messages, and the server can send notifications or progress updates in a consistent way. Statefulness matters because tool execution isn't always instant. A search files tool might be fast. A Raindex aside tool might take minutes. A create a report tool might be queued. If you treat every tool as a stateless request-response call, you end up reinventing long-running task patterns poorly. Polling endpoints, random retries, duplicate actions, and half-finished operations that look successful to the model. And remember, agent loops amplify ambiguity. If a tool call is slow or flaky, the model doesn't just wait. It tries again, or it tries something else, or it assumes the action completed and moves on. So you need explicit patterns for state, progress events, correlation IDs, and idempotency keys where actions mutate systems. That's not optional. Now connect this back to Microsoft reality. STDIO is your dev loop. HTTP is your enterprise loop. Local MCP servers are for building and experimenting. Remote MCP servers are for governance. Entra-backed AUth, APIM, front doors, logging into Sentinel, and policy enforcement that doesn't depend on whether a developer remembered to do the right thing. And here's the rule you should tattoo onto every architecture diagram. Transport choices change trust boundaries, not just latency. So before you ask functions or container apps, ask the real question. Where does this tool run? Under which identity? With what policy? And what happens when it fails? Because if you can't answer that, you don't have an MCP architecture. You have a demo. MCP meets Microsoft. Why this fits too well. This is where MCP stops being an AI developer trend and starts looking like a Microsoft platform move that was going to happen anyway. Because Microsoft doesn't really build products around models. Microsoft builds products around governance. And that distinction matters because MCP is, architecturally, a governance primitive pretending to be an integration protocol. Most ecosystems treat tool integration as a convenience feature, something you add after the model works. Microsoft environments treat integration as the blast radius. Identity, policy, audit, retention, e-discovery, DLP, those aren't add-ons, they're the shape of the environment. And when you drop LLM tool use into that environment, you don't get to treat it like a weekend project. You need a boundary. Microsoft's posture is identity first. Entra sits in the middle of everything, not because Microsoft loves auth prompts, but because identity is the only stable perimeter that survives cloud, remote work, and SaaS sprawl. That means MCP's host mediates authority model plugs into existing instincts. Make the caller prove who they are, make the token express what they can do, and log the action in a way that maps to an accountable principle. MCP doesn't magically solve that, but it gives you a consistent place to attach it. Now look at the Copilot ecosystem pressure. Copilot exists across multiple hosts, M365 surfaces, Teams, Windows, Edge, VS Code, custom apps, and whatever the next assistant endpoint becomes. If tool integrations are bespoke per host, Microsoft inherits the worst problem on Earth, 1,000 inconsistent adapters to the same enterprise systems, each with different permission handling and audit semantics. That is not a scalable platform strategy. So MCP aligns with an inevitability. Tool integration has to become a shared substrate. Not because it's elegant, but because it's the only way to keep Copilot-style experiences consistent across hosts without rebuilding the tool ecosystem for every new client. And Microsoft is structurally built for choke points. Azure is a control plane company. The value isn't we can call an API. The value is we can put policy in front of the API. Resource groups, RBAC, private link, APIM, Key Vault, Defender, Purview, these are all different ways of saying the same thing. Control by centralizing enforcement. MCP is the same pattern applied to model tool use. Now, the part most people miss, Microsoft already has the data gravity that makes MCP useful. Graph and SharePoint aren't just APIs. They're the enterprise's nervous system. Files, permissions, groups, chats, meetings, tasks, identities, devices, risk signals. When you let a model use tools in that ecosystem, the failure mode isn't the model made a mistake. The failure mode is the model acted with the wrong authority across a graph of interconnected resources. That's why MCP fits. It forces you to treat tools as declared capabilities with explicit contracts, not whatever endpoint we can reach. It encourages an integration boundary where you can standardize the boring parts: tool naming, schemas, identity handling, logging, and rate control. And yes, Microsoft is culturally inclined to standardize the boring parts. That's half the platform. There's also a compliance angle that's not optional. Enterprises want audit trails that survive incident response and regulatory review. MCP's host-mediated model makes that feasible. You can correlate a user prompt to tool selection, to tool execution, to downstream API calls. Not perfectly, not automatically, but feasibly. Without a protocol boundary, you end up scraping logs across 5 layers and still not knowing what the model saw or why it chose the tool it did. So MCP fits Microsoft because it reinforces Microsoft's default operating model. Reduce entropy by making boundaries explicit, make identity central, and make enforcement attached to a consistent interface. It's not AI stuff. It's integration architecture catching up to a world where the caller is probabilistic and the enterprise environment is not allowed to be. MCP versus proprietary Copilot extensions. Open standard versus platform gravity. This is where people try to turn MCP into a culture war. Open standard good, proprietary bad. That's not architecture, that's branding. In Microsoft land, you're going to live in a hybrid world for a long time. Some capabilities will come through Copilot native extension points. Some will come through open protocols like MCP. The question isn't which one is morally superior. The question is where you want to pay your integration tax. Start with what proprietary Copilot extensions optimize for: speed inside a single platform. When Microsoft owns the host, the identity integration, the UX surface, and the distribution channel, they can deliver a very coherent experience. Permissions prompts feel consistent. Admin controls show up in familiar places. Telemetry is good enough for most deployments because it's standardized to the platform. That's the upside of platform gravity. It reduces choices, and reduced choices feel like simplicity. But platform gravity also captures your integration semantics. You build the tool the way the platform wants it built. You name things the way the platform wants them named. You accept the platform's interpretation of what an action is, what approval is, what logging is, and how versioning should work. If Microsoft changes any of that, your integration isn't wrong, but it becomes out of date. Then you get drift not in your backend API, in the user-facing behavior of the agent. That's the part enterprises hate because it's difficult to regression test. Your security review can validate scopes and endpoints. It cannot easily validate the model now chooses this action more often because the host changed how it presents tools. Now, MCP's value proposition in this comparison is narrower and therefore more durable. It standardizes the boundary between host and tool server. You can build a SharePoint MCP server once with a stable contract, and multiple hosts can consume it. IDE agents, internal chat apps, whatever Copilot surface comes next. The host experience can evolve without forcing you to rebuild the tool server every time. So the integration investment becomes less host-shaped and more enterprise-shaped. That distinction matters. But don't mistake open protocol for free. With MCP, you inherit responsibility for the boundary. You have to decide how discovery works inside your organization. You have to decide how you version tool schemas. You have to decide how you authenticate remote servers. You have to decide how you log and attribute tool calls. You have to decide what you will not allow. With a proprietary extension surface, Microsoft makes those calls for you. With MCP, you make them. Enterprises tend to pretend they want flexibility. They don't. They want survivability. So here's the practical trade. Proprietary Copilot extensions maximize time to first demo, and MCP maximizes time to still working in 2 years. One optimizes for initial integration velocity inside Microsoft's ecosystem. The other optimizes for portability and governance across an ecosystem that won't stay still. Now, the deeper issue, ecosystem effects. A proprietary extension model creates a winner-takes-most gravity well. Integration value accrues to the platform owner because the extensions are shaped to that platform. Tool vendors build where the users are and users stay where the tools are. It's efficient. It's also how lock-in becomes just the way things are. An open protocol like MCP flips that incentive. Tool builders target the protocol and hosts compete on experience. That's a different market structure. Less captured by any single client, more resilient to shifts in model providers and app surfaces. And yes, Microsoft can participate in that world while still running proprietary surfaces. That's the point. Protocols don't kill platforms. They limit how much the platform can trap you at the integration boundary. So if you're deciding where to standardize, the rule is simple. Standardize at the boundary you can't afford to rebuild. If your business logic lives in the tool server, standardize that with MCP. If your differentiator is the host UX inside Microsoft 365, then use COPILOT extensions where they fit. But don't confuse those layers, because the moment you build enterprise integrations directly against a single host's extension model, you are not building AI capability. You're leasing it, and lease terms change. Microsoft reference architecture, where MCP sits in the stack. Now put all of this into a Microsoft-shaped architecture, because protocol only becomes real when you can point at a diagram and say, that box is where authority is enforced, and this other box is where entropy leaks in. At a high level, an MCP-enabled system in Microsoft land has 5 moving parts: the model, the host, the MCP client, the MCP server, and the enterprise systems behind it. The model is boring by design. Azure OpenAI, Foundry models, whatever you're using, the model reasons. It does not execute, it does not authenticate, it does not own credentials. If you let the model become the actor, you're not building an agent system, you're building a breach narrative. The host is where the real power sits. This is your application, a Copilot-like chat surface, a Teams app, a custom web app, an internal ops assistant, or an IDE agent. The host is the only component allowed to see the full conversation and the user's intent end-to-end. That's not a convenience detail, that's the privacy and governance boundary. Inside the host lives the MCP client. Think of it as the protocol adapter and session manager. It negotiates capabilities with servers, lists tools, invokes tools, and receives results. But more importantly, it's the mechanism that allows the host to decide what the model is even allowed to ask for. This is the first Microsoft native reframe. The host is an authorization broker, not an AI wrapper. It decides which MCP servers are connected, which tools are exposed, which resources can be fetched, and what context gets forwarded. In practice, it's the thing that turns user asked a question into a scoped attributable action was executed. Now the MCP server, this is the integration boundary. It wraps enterprise systems, Graph, SharePoint, SQL, ServiceNow, whatever, into a declared set of capabilities. Tools are your actions, resources are your context surfaces, prompts are your standardized entry points. And the server is where you translate messy backend reality into deterministic contracts that a probabilistic caller can't ruin. But don't confuse integration boundary with security boundary. In Microsoft environments, security is enforced by identity plus policy, not by your Python code behaving politely. So the reference architecture needs explicit integration points that enterprises already trust. First, Entra ID. Every serious deployment uses Entra to prove identities, issue tokens, and express least privilege. The host authenticates the user. The host then either calls the MCP server with a delegated token model, or the MCP server operates under a workload identity model. We'll go deep on the token flows next, but for now, the architectural rule is simple. Tool execution must map to an accountable principle, and Entra is the only system that can make that defensible at scale. Second, Key Vault. If your MCP server needs secrets for downstream APIs that aren't Entra integrated, for certificates, for legacy systems, Key Vault is where those secrets live. Not in environment variables, not in app settings copied between environments, not in temporary service principal secrets that never expire. Key Vault isn't exciting, it's where entropy goes to die if you actually use it. Third, Azure API Management. This is where you put governance at the edge. APM doesn't replace MCP. It governs exposure, it validates tokens, enforces quotas, applies rate limits, does request transformation when needed, and gives you central logging. Most importantly, it gives you a consistent place to say, this tool is allowed for these callers from these networks at this rate, with this retention and with this cost profile. MCP standardizes tool invocation. APM standardizes the consequences. Fourth, logging and monitoring. In a Microsoft stack, that means Azure Monitor, Application Insights, Log Analytics, and then Sentinel if you're serious. The reference architecture should emit audit-grade events: tool name, input schema version, caller identity, correlation ID, downstream dependency calls, and outcome. If you can't answer who did what in one query, you built a demo, not a platform. Now, place enterprise systems behind the MCP server. SharePoint and Graph, databases, line of business APIs, even legacy SOAP endpoints. The point is that MCP servers are adapters with contracts, not direct pipes. You're not exposing your raw backend. You're exposing an intentional capability surface. So the stack looks like this. User interacts with host. Host authenticates with Entra, model reasons within the host. Host invokes MCP tools via MCP client. MCP server enforces its contract. APIM and Entra enforce policy. Backends do the work. Telemetry proves what happened. And the next question is the only one that matters. Which identity is actually holding the knife when a tool runs? Identity flow 1. Entra on behalf of delegated authority, not LLM God mode. So answer the knife question. When a tool runs, whose authority is it using? If you can't say that in one sentence, you don't have an AI architecture. You have a liability generator. The cleanest place to start is Entra on behalf of, because it forces a truth enterprises love to avoid. Most AI integrations quietly run as an app with broad permissions, and then everyone acts surprised when it behaves like an app with broad permissions. On behalf of is the opposite. It's delegated authority. It's the platform saying the user is the actor, the application is the broker, and the downstream call must remain attributable to the user's permissions and the user's context. That distinction matters. Here's the core idea in plain terms. A user signs into the host. The host gets a user token from Entra. Then, when the host wants to call an MCP server, it passes a token or a proof of user identity to that server. The MCP server doesn't just reuse that token blindly. It exchanges it using the OBO flow to obtain a new access token for the downstream API, like Microsoft Graph, scoped for the user and for the specific audience. So the sequence is simple. User authenticates to the host. Host receives a delegated token. MCP server exchanges that token on behalf of the user. MCP server calls Graph or SharePoint with a delegated token representing the user, and the result comes back. What this buys you is not security theater, it buys you scope trimming as architecture, because delegated tokens carry scopes. Scopes are the contract of least privilege. When the tool is list documents in this site, the server requests the specific graph scopes it needs. And Entra enforces whether that user has consented, whether the tenant allows it, and whether policy conditions apply. The model never gets God mode. The model gets a request path that can be denied, and that denial is a feature, not an outage. Now, the part people get wrong. OBO is not about letting the model do user stuff. It's about preserving accountability. If an MCP tool uses OBO, your audit trail can say, this action happened because this user asked for it through this host, and the downstream system evaluated the user's own permissions. That's how you survive incident review, because the question will be who did it, not which model suggested it. And if your tools run under app-only permissions, your answer becomes the service principal, which is another way of saying nobody. OBO is also the clean way to separate knowledge access from action authority without inventing custom logic. If the user can read a document in SharePoint, Graph will allow the call. If the user can't, Graph will deny it. Your MCP server doesn't have to become a parallel authorization system. It becomes an integration boundary that respects the enterprise authorization engine. Entra and Graph remain the decision engine. Your server becomes a translator, not a judge. Now the failure modes, because OBO is not magic. First, consent and permissions sprawl. OBO requires that your app is configured with the right delegated permissions and that admin consent is handled intentionally. If you treat admin consent as just make it work, you reintroduce the same entropy you were trying to eliminate just earlier in the lifecycle. Second, token handling. The host must not leak user tokens into places they don't belong. If you forward user tokens to random downstream systems or third-party MCP servers, you've turned your delegated model into a portable credential theft mechanism. Third, conditional access. This is where Microsoft environments get serious. Conditional access might require compliant devices, specific locations, or MFA for certain resources. OBO doesn't bypass that. It inherits it. That's good because it means your tool execution respects the same risk posture as the rest of the tenant. But it also means your tool calls can fail for reasons that look non-technical to developers. They aren't non-technical. They're policy doing its job. So if you implement OBO, you need to design for denial, clear error mapping, fail-close behavior, and user-visible explanations that don't leak sensitive policy detail. Because access denied is a correct outcome, and that's the takeaway. OBO turns MCP tool execution into delegated authority with auditability, scope trimming, and policy inheritance. It is the closest thing you get to a deterministic security model in a probabilistic tool selection world. Now the uncomfortable contrast. Same MCP tool surface, different blast radius when you switch to managed identity. Identity flow 2, managed identity plus Microsoft Graph, the operational baseline. Now take the same idea, an MCP server calling Microsoft Graph, and remove the user. That's the managed identity pattern. This is the operational baseline because it matches how Azure is supposed to work. Workloads authenticate as workloads. No secrets. No copied client secrets in app settings. No temporary certificates that become permanent because nobody owns rotation. Just a resource in Azure with an identity, asking Entra for a token and calling Graph. Clean. But don't confuse clean with equivalent to OBO. It isn't. The authority model is different, and that changes everything about accountability. With managed identity, the principal is the workload. The MCP server is the actor. So when the host invokes a tool and the tool ends up calling graph, the downstream system sees an app identity, not a user identity. That means the audit question changes from which user did this and to which workload did this, and that can be acceptable. Sometimes it's the correct model. The right use cases are the boring ones that keep enterprises alive. Background indexing, scheduled classification, metadata normalization, nightly reports, content inventory, and controlled automation that's explicitly not user-driven. You're building a service. The service should have a service identity. This is also why managed identity is the baseline for shared MCP servers. If your organization wants a centrally hosted SharePoint Graph MCP server that multiple hosts can use, Teams assistants, internal chat apps, dev tooling, managed identity is the simplest identity story that doesn't involve user token forwarding across every client. Mechanically, it looks like this. The MCP server runs on an Azure host that supports managed identity, functions, container apps, AKS with workload identity, whatever. The server requests an access token from Entra for the Microsoft Graph audience. It calls Graph with that token. Graph evaluates app permissions and directory roles assigned to that managed identity. The call succeeds or fails. The server returns a deterministic response to the host. No user tokens ever cross that boundary. And that's the benefit: fewer moving parts, fewer consent flows, fewer conditional access surprises tied to user posture. The system behaves like any other server-to-server integration, but there's a price. You lose user-level accountability by default. If a tool mutates data, create a Teams message, update a SharePoint list item, modify permissions, you've just created an action surface that is not naturally attributable to the user who asked for it. You can add your own logging, of course. You can stamp requested by user X into telemetry, but that is not the same as Graph enforcing user permissions. It's your app asserting a story, and incident reviews don't accept the app says so as a strong boundary. So the correct pattern is to treat managed identity as operational authority, not delegated authority. Keep the tools read heavy. Keep the mutation tools rare, narrow, and gated behind explicit approvals in the host. And never pretend that because the user asked means the user is accountable when the token is app only. Now the failure mode. This is where managed identity turns into silent privilege expansion. Because it's so easy. A team needs one more graph capability. They add one more application permission, everything works. Then another team needs another capability, another permission. Then 6 months later, your managed identity has broad read access across mail, files, users, groups, sites, because every request was individually reasonable. And collectively, it became a super user. That's how security debt grows in Microsoft environments, not through one catastrophic misconfiguration, but through cumulative permission accretion that nobody revisits. Managed identity doesn't prevent that. It accelerates it because it feels safe. So if you use managed identity for MCP servers, you enforce 3 disciplines. First, explicit scoping. Prefer graph application permissions that are narrow, and when possible, scope access to specific sites or resources rather than tenant-wide. Don't build a tenant-reader identity unless you actually mean it. Second, role separation. Don't run every MCP server under one identity. Different tool surfaces get different identities. Read-only servers and write-capable servers do not share principals. Shared principals are entropy generators. Third, audit as architecture. Every tool call emits a structured event. Tool name, parameters, graph endpoint called, result, correlation ID, and the calling host identity. That's the minimum bar for survivability. So managed identity is the baseline because it's operationally sane and Azure native, but it is not a free substitute for OBO. It's the same tools, the same server, the same graph calls, and a completely different blast radius. Identity flow 3, service principal plus Azure API Management, governance at the edge. Now take the managed identity pattern and make it enterprise scale on purpose, because managed identity answers how does the workload authenticate, but it doesn't answer how do we govern exposure when the callers multiply and the traffic turns bursty. That's where the service principal plus Azure API Management pattern shows up, not because it's trendy, because it's the only place you can consistently enforce policy when the tool surface becomes a shared utility. Here's the shape. Your MCP server is still the integration boundary. It still exposes tools, resources, and prompts, but you don't let random hosts call it directly. You put Azure API Management in front of it, and you treat APM as the enforcement layer. Validate tokens, apply throttles, do quota, log everything, and reject anything that doesn't match your policy posture. In this pattern, the caller is a service principal. That might be the host application itself, or it might be a broker component that fronts multiple hosts. Either way, it's app-to-app auth, client credentials. Deterministic, boring, which is what you want at the edge. And before anyone panics about service principal equals broad permissions, Separate two concerns that people keep mixing. The service principle is for calling the MCP server. The MCP server's downstream identity is a separate decision. The server can still use OBIO for user-delegated operations, or manage identity for operational calls, or even a different app identity for downstream systems. APM doesn't force one model, it forces one entrance. That's the point. APM is where you standardize the gate, not where you collapse all identities into one blob. So what does APM actually give you that matters in an MCP world? First, authentication and authorization at the boundary. APIM can validate Entra-issued JWTs, enforce issuer, audience, and claims, and reject callers that aren't who they claim to be. And because it's centralized, you don't end up with every MCP server team implemented auth differently. That inconsistency is where breaches hide. Second, throttling and quotas. Agent traffic is not normal traffic. It is spiky, recursive, and sometimes stupid. When a model hits a transient error, the agent loop tends to retry. When a tool call is slow, the model tends to try alternate tools. When you expose 10 tools, you don't get 10 calls, you get call cascades. APIM is where you stop that from turning into a back-end denial of service you did to yourself. Rate limits per client, quotas per time period, burst control. And if you want to be sane, you enforce different limits per tool category. Read tools get higher throughput, write tools get tighter limits, and expensive tools get explicit quotas tied to cost centers. Third, transformation and normalization. This is not about making JSON pretty. It's about enforcing stable contracts. If your MCP server evolves, APIM can help you keep a stable external surface while you transition internals. Version routing, header-based feature flags, or even schema validation if you go that far. Enterprises don't want surprises. They want managed change. Fourth, observability and audit trails that don't require you to stitch logs from every app team. APIM gives you a single choke point where every request and response can be logged with correlation IDs and client identity. You still need application-level logs inside the MCP server, but APIM becomes the authoritative record of who called what when. And that matters because MCP is a tool protocol. Tool calls are actions. Actions require attribution. Attribution requires a reliable ledger. Now, the uncomfortable boundary question, where does MCP end? MCP standardizes how tools are described and invoked. It does not standardize enterprise governance. It doesn't enforce your rate limits. It doesn't implement your tenant restrictions. It doesn't control your budgets. It doesn't decide what allowed means. APM is where those enterprise controls live. So the clean framing is this. MCP is the tool invocation protocol. APM is the policy engine at the edge. Entra is the identity issuer and authorization substrate. And your MCP server is the translator that keeps back-end complexity from leaking into a probabilistic caller. Once you have this pattern, you can finally answer the CFO question and the incident reviewer question with the same architecture. How do we control cost? How do we prove accountability? Because the edge is governable. Now we can build the SharePoint and Graph MCP server without pretending the boundary will take care of itself. Hands-on anchor, designing the SharePoint plus Graph MCP server. Now we stop talking about protocols like their philosophy and we build one. Not a toy Hello World MCP server. A SharePoint plus Microsoft Graph MCP server that survives contact with an enterprise tenant. SharePoint is the perfect trap for this because it looks simple until you ask one question, who can see what? Then you realize permissions aren't a Boolean, they're an inheritance graph. With exceptions, broken inheritance, sharing links, guest access, sensitivity labels, and whatever else the organization bolted on during the last 5 reorganizations. That is exactly why this is the right anchor. If you can make MCP behave in SharePoint, you can make it behave anywhere. So the first architectural decision is not what language you use or where you host it. It's how you draw the boundary between context and authority. Because SharePoint makes it painfully obvious when you get that wrong. Start with the server contract. What resources exist, what tools exist, and what prompts exist. Resources come first because if your MCP server can't supply stable context, the model will improvise. And improvisation inside SharePoint turns into open the wrong document and summarize it confidently. So define read-oriented resources that are predictable and low risk. A resource for site metadata is a good example. Site ID, site URL, display name, classification, sensitivity label if available, and maybe the default document library identifiers, not the documents themselves, metadata first. A resource for permission context is even more important, whether the caller is using OBIO or app only, which identity is active, and what scope is being requested. This isn't for the model's curiosity, it's for determinism. If the host and server can fetch a small structured permission context, the host can decide whether to allow downstream tool calls without guessing. A resource for content types and columns is also valuable, because in SharePoint, list data without schema is just noise. Give the model stable names for fields, expected types, and allowed values. Otherwise, it will hallucinate a column called status, because every system has a status, and then your tool call fails and the loop retries until your backend hates you. Now tools. Tools are where the damage happens, so tools need strict schemas and narrow meaning. Avoid the generic search. SharePoint search is not one thing, it's multiple things with different authorization surfaces and different failure modes. So instead, define tools with explicit scope and intent. A tool like SharePoint search documents insight with required site ID and query text, plus optional filters that you explicitly constrain. File type, modified after, author UPN, sensitivity label, top. No freeform filters object. You want schema discipline, not creativity. A tool like SharePoint to get document metadata takes a stable identifier, returns stable fields, and never returns full content by default. If you want content, you make that a separate tool. SharePoint, get document content with explicit max bytes, and the host must enforce policy around it. A tool like GraphList user groups is a trap unless you tightly scope why it exists. In an enterprise tenant, enumerating group membership is sensitive, so if you need it, constrain it to a specific purpose. Graph check user access to site, where the server answers a yes, no, plus evidence fields, instead of dumping raw group data. Then prompts. Prompts are templates that standardize how humans invoke common workflows. For SharePoint, the obvious ones are things like review this document for policy compliance or summarize changes since last week for this site. But you keep prompts honest. They don't grant permissions, they don't bypass approval, and they don't magically solve injection. They just reduce human drift. Now the identity model ties it together. If the host uses OBO, your tools operate under user-delegated access, and SharePoint and Graph become the enforcement engines. If the host uses managed identity, your tools must be scoped to operational tasks, and your server must log attribution explicitly because Graph won't do it for you. If you front the whole thing with APM, you get rate control and a ledger of calls that doesn't depend on every developer remembering to instrument. Finally, you define what fail closed means. If the tool can't prove site scope, it refuses the call. If a document is overshared or unlabeled and your policy requires classification, the tool refuses the call. If the query is ambiguous, the tool refuses the call and forces elicitation through the host. This is the real value of MCP in Microsoft land. Not that the model can reach SharePoint, that the model can't reach SharePoint unless you let it. Contract design, tool schemas, naming, and the art of avoiding overlap. Now comes the part everyone skips because it feels too API-ish at contract design. If you get the contract wrong, MCP doesn't save you, it just makes your mistakes reusable. And the first mistake is naming. Most teams name tools like they name helper functions, short, generic, and optimistic. Search, get files, create item. That works when a human developer reads the code and understands context. A model doesn't have that context. A model sees a menu of tools with descriptions. Then it guesses. So naming has one job, make guessing unnecessary. The rule is verb first, scope second, and domain explicit. Not search. SharePoint search documents inside. Not get. SharePoint get document metadata. Not update. SharePoint update list item fields. The name should answer what system, what object, what scope, what action. Every extra syllable is cheaper than an incident review. Now the next rule, never create overlapping tools. If you expose 3 tools that all feel like search, the model will pick the wrong one eventually. Not because it's dumb, but because you asked it to choose between ambiguous options. So you define one canonical tool per intent per scope. If you need different search semantics, graph search versus SharePoint REST versus search API, you hide that inside the server. You don't force the model to know which backend is better. The server is the translator. The model is not your integration engineer. Now schemas. Your input schema is not a convenience. It is the boundary that keeps prompt injection from becoming tool injection. If you accept freeform strings where you actually need constrained fields, the model will smuggle instructions into parameters. It won't even mean to. It's just optimizing for get the job done. So constrain inputs until the model can't be clever. If a tool needs a site, require a site ID, not site URL or site name or whatever you can find. One identifier. If a tool needs a time window, require ISO 8601 timestamps, not last week. If a tool needs a filter, make it an enum, not filter text. And if you absolutely must accept freeform text, you treat it as untrusted, you validate it, you log it, and you design the tool so the worst case is bad query, not privilege escalation. Outputs matter just as much. Most MCP servers return whatever the backend returned because it's easy. That is how you make the model reverse engineer your system at runtime. Instead, you return stable shapes. For a search tool, a list of results with a strict object schema. Each result has ID, title, web URL, last modified date time, author, and classification signals you can reliably provide. No polymorphic blobs. For metadata tools, predictable fields, predictable null behavior, predictable paging. If there's paging, return the next cursor. Don't dump @data next link and call it a day. And here's the uncomfortable part. You need to design outputs for audit, not just for the model. If a tool fetches a document, include the permission path you used, delegated user token or app only. Include the resource identifiers. Include a correlation ID that ties back to logs. That's how you prove what happened later, when later becomes why did this tool access that file. Now, versioning in MCP capability surfaces are discoverable. That's good. But it tempts teams into silent breaking changes. Rename fields, change meanings, add optional parameters that alter behavior. That's how deterministic contracts turn probabilistic. So treat capability versioning as a first-class design input. Either version your tool names like SharePoint, Search Documents Insight v2, or version your server capabilities explicitly and keep old shapes alive until clients migrate. It's not elegant, but it's survivable. Finally, the anti-overlap discipline needs a naming taxonomy. Within a server, tools should follow a consistent pattern. System prefix, SharePoint, graph, SQL. Action verb, search, get, list, create, update, delete. Scope qualifier, inside, in library, by ID. Object noun, documents, list, items, permissions. That's not aesthetics. It's how you prevent the 3 search tools problem that Theo from Anthropic called out. Overlapping tools confuse models, and confusion becomes unpredictable tool selection. And when tool selection becomes unpredictable, your security model becomes probabilistic. So yes, contract design is boring. That's why it works. The whole point of MCP is to give a probabilistic model a deterministic capability surface. Names remove guesswork, schemas remove ambiguity, output shapes remove interpretation, versioning removes drift. If you do those 4 things, MCP becomes governable. If you don't, MCP becomes just another way to scale your glue code. Hosting decision point, functions versus container apps versus AKS. Now you've got a contract. You've got tool names that don't overlap. You've got schemas that don't invite improvisation. So the next question is painfully unglamorous. Where does the MCP server live? This is where teams pretend they're discussing cost and latency, but they're really choosing blast radius and operational ownership. Hosting is not a runtime choice. It's a pager choice. Start with Azure Functions. Functions are the default reflex because they feel like small tools. 1 function per tool, scale to 0, pay per execution. It looks like alignment. But MCP servers, especially remote ones over HTTP, don't behave like typical webhook handlers. They behave like interactive services that get called in bursts, in loops, and sometimes in rapid retreats because the model is trying to complete a task. Functions can work if your MCP server is truly stateless per call and your tools are short-lived. Read-only queries, quick lookups, narrow transformations. It's great for background automation tools too, where a cold start is annoying but not catastrophic. The catch is cold start and connection behavior. In an interactive agent loop, a few seconds of startup delay doesn't just slow the user, it changes model behavior. The model sees tool is slow, tries a different tool, or retries, and now you've built an accidental traffic amplifier. Functions also push you toward fragmented deployments, 1 server per team, per toolset, each with slightly different auth handling, logging, and network controls. That is not a platform, that is distributed entropy. Now, Azure Container Apps. Container apps is the middle path that enterprises should default to and rarely do because it's not serverless pure and it's not Kubernetes heroic. It's a managed container runtime with sane scaling, optional scale to 0, and a predictable execution environment for HTTP services. For MCP servers, that matters because you typically want a single process that owns the tool registry, can maintain session-level behavior if needed, and can handle streaming patterns without you fighting the platform. You also get cleaner identity stories. Managed identity integration is straightforward. Network boundaries are clearer. You confront it with APIM without weird workarounds. And your deployment artifact is a container image, which means your DevX and your runtime are finally the same thing. The trade is that container apps forces you to act like you're running a service. You need health probes, resource limits, log strategy, and you need to accept that scaling is not free. A burst of tool calls becomes a burst of container replicas unless you control concurrency intentionally. Now, AKS is the correct answer when you already operate Kubernetes as a first-class platform, not when you might need it later. Kubernetes isn't a hosting option, it's an operating model with an attached tax. AKS makes sense if you need strict network segmentation, advanced routing, custom sidecars, service mesh integration, or if you're co-locating MCP servers with other internal services in a cluster that's already governed and monitored. It's also reasonable if you're building a multi-tenant MCP platform with strong isolation requirements per team or per environment. But here's the architectural truth. If this is your first MCP server and your first question is, should we run AKS, you're early solving. You are optimizing for theoretical future scale instead of today's boundary correctness. An MCP doesn't fail first because you didn't have enough nodes. It fails because you didn't have deterministic contracts, enforceable identity, and a failure model that closes doors instead of opening them. So choose based on the real constraints. If you need to move fast and your tools are short-lived, Functions can be fine, but treat it as a stepping stone, not the destination. If you want a stable, governable HTTP service with sane operations, container apps is the default. If you already live in Kubernetes and you need Kubernetes class controls, AKS is reasonable, but only if you're willing to pay the ongoing cost in human attention. Because the question behind every hosting decision is simple. When this tool server misbehaves at 2 a.m., who gets blamed, who gets paged, and what system is now at risk? SLOs and failure modes, latency, timeouts, and failing closed. Now assume you picked a host. Great, your next problem is that agent traffic doesn't behave like human traffic, so you need SLOs, not vibes. For interactive tool use, the only number that matters is perceived responsiveness. A good target is P95 around 300 to 500 milliseconds per tool call, end-to-end. Not back-end time, end-to-end. Auth, network, execution, serialization, logging, because the model doesn't care why it was slow. It just reacts, and when it reacts, it amplifies. A slow tool triggers retries. Retries trigger concurrency. Concurrency triggers throttling. Throttling triggers more retries. That loop is how you DOS your own tenant. So set explicit timeouts, short for read tools, longer only when the tool is designed for long-running work with progress reporting. If the tool can mutate state, it must be idempotent, or you will eventually duplicate actions under retry pressure. Then decide fail closed versus fail open. Fail open feels helpful. It's also how policy turns into a suggestion. If oath fails, deny. If scope is unclear, deny. If classification is missing and policy requires it, deny. Denial is stability. MCP and developer experience, strong interfaces, fewer hallucinated integrations. Now here's the part that gets MCP adopted inside engineering teams. Not governance. Developer experience, because most teams don't start a project by saying, I'd like a new control plane boundary. They start by saying, I'm tired of rewriting this integration for every agent framework, and I'm tired of the model guessing my API shape wrong. This is the uncomfortable truth. The average LLM integration fails because the interface is vague, not because the model is dumb. When people say the model hallucinated, what they usually mean is, we handed a probabilistic caller an ambiguous tool surface and then acted surprised when it guessed. MCP's real DevX win is that it makes ambiguity expensive. It forces you to declare the capability surface up front, tool names, descriptions, schemas, output shapes. And once you have that, you can do something that enterprises have always needed but rarely got from AI tooling. You can treat tool integrations like software contracts again. That distinction matters. Because REST APIs and OpenAPI do this for developers, but LLM tool use introduces an extra problem. Tool discovery and selection happens at runtime, inside a reasoning loop, by a caller that does not read your docs like a human reads docs. So MCP gives you a structured inventory of capabilities that the host can present to the model consistently, and it gives you schemas that the host can validate before anything runs. That means fewer hallucinated integrations in practice, fewer invented parameters, fewer wrong endpoint assumptions, fewer it tried to call search with a site name when you needed a site ID. Not eliminated, reduced. And reduction is the whole game in enterprise architecture. Now, the second DevX upgrade is that MCP makes testing possible in a way that most agent toolchains quietly don't. When tool invocation becomes a declared contract, you can write contract tests that validate, does this tool accept this schema? Does it reject invalid inputs? Does it return the output shape you promised? Does it fail closed when identity isn't present? And you can run those tests without a model in the loop. That's not a small improvement. That's the difference between AI prototype and integration that survives a quarter. Because if you can't test the tool layer deterministically, you end up testing the entire system through the model, and the model will never give you stable test cases. It's probabilistic by design. So MCP lets you split the work. The model is tested for behavior and guardrails. The tools are tested for contracts and policy. Two different test strategies for two different types of components. That is what mature engineering looks like. Now talk about versioning, because every integration eventually changes. Schemas evolve, backends evolve, requirements evolve. And if you handle that by just update the code, you will break clients you don't even know exist, especially in an MCP world where multiple hosts can connect to the same server. So the DevX benefit is not that MCP magically versions your tools. It's that MCP gives you a place to version them cleanly. You can add a new tool without deleting the old one. You can introduce V2 shapes while keeping V1 alive. You can mark capabilities as deprecated. You can run compatibility checks in CI. And the clients don't need to be rewritten just because you changed the backend implementation, because the contract is the thing you treat as durable. Again, survivability over novelty. But there's a warning here, and it's the same warning from earlier sections. If you treat MCP as faster plugins, you will rebuild the glue code anyway. You'll create 10 overlapping tools because it feels convenient. You'll expose raw backend responses because it's faster. You'll accept freeform parameters because the model will figure it out. And then you'll spend the next 6 months writing prompt band-aids and system messages to compensate for a capability surface that never had discipline. That's not MCP failing, that's you refusing to design an interface. And MCP can't fix that, because MCP is not intelligence, it's a protocol. A protocol can enforce structure, but it cannot enforce intent unless you actually embed intent into the structure, names, schemas, scoping rules, and fail-closed behavior. So the clean takeaway for DevX is simple. MCP doesn't make agents smarter, it makes integrations less ambiguous. And when you reduce ambiguity, you reduce hallucination, you reduce retries, you reduce incident fuel, and you reduce the amount of custom glue code you need to keep rewriting every time the ecosystem shifts. That's why engineers like it. Not because it's magical, because it's boring in exactly the right place. Tooling integration, VS Code, GitHub Copilot, CI, CD, and inner source. Once you accept that MCP is a contract boundary, the next question is obvious. How does it actually live inside real engineering workflows? Because nobody deploys a protocol. They deploy code through pipelines with approvals under the comforting illusion that someone reviewed it. So start with VS Code, because that's where most MCP adoption shows up first. Developer tools and agent-enabled IDEs. Not because IDEs are the center of the universe, but because they're where tool use is easiest to demonstrate. You can wire up an MCP server locally, expose a couple of tools, and suddenly your assistant stops being a text generator and starts being a bounded actor. But don't let that demo lie to you. VS Code integration is a DevX feature. It is not an enterprise boundary. The enterprise boundary is the MCP server contract and the identity model behind it. VS Code is just one host, a convenient one. So the right mental model is this. VS Code is where you develop and test MCP servers. Your organization's platform is where you publish and govern them. Now layer GitHub Copilot on top of that. Copilot helps you write the server quickly. It will happily generate tool schemas, JSON RPC handlers, and boilerplate. That's fine. It's also not the hard part. The hard part is deciding what tools should exist at all, because Copilot will default to generic convenient tools. Search, get, update. And you already know what happens when you expose ambiguous capabilities to a probabilistic caller. So use Copilot for speed, but you still own the boundary design. If you delegate boundary design to an autocomplete engine, you're not moving faster. You're moving the incident earlier. Now the part most teams ignore until they get burned. CI/CD. If MCP is going to be the end of custom AI glue, then MCP servers must become shared assets. And shared assets require the same discipline you apply to APIs: linting, testing, versioning, and deployment gates. So treat an MCP server like a product with 3 non-negotiables. First, schema validation in CI. Every tool input schema and output shape should be machine validated, not reviewed in a PR. Validated. This is where you catch the slow death of contract drift. Renamed fields, changed meanings, loose types creeping back in. Second, contract tests. For each tool, test the success path and the denial path. Especially the denial path. If identity is missing, does it fail closed? If scope is wrong, does it refuse? If the request is ambiguous, does it force elicitation through the host instead of guessing? Your model is not your test harness, your pipeline is. Third, policy gates on deployment. If you run MCP servers in Azure, you already have the governance tooling, Azure policy, APIM policies, deployment approvals, environment separation. Use them. Don't ship new tools straight to production because it's just an internal assistant. Internal is where the most expensive breaches live. Now, inner source. This is where MCP becomes a real organizational multiplier or just another pile of half-maintained repositories. In most enterprises, every team builds the same integration 3 times. One for their app, one for Power Automate, one for whatever agent framework they're experimenting with. And they all drift. Different naming, different permissions, different behavior, different logs, same backend. MCP can collapse that duplication, but only if you treat MCP servers as shared products with shared ownership. Inner source is the mechanism. Publish MCP servers as internal packages with documentation, versioning, and a contribution model. One team owns the boundary, other teams contribute improvements. Everyone consumes the same capability surface. That's how you reduce tool sprawl without creating a central bottleneck. And it also changes how you think about platform engineering for AI. The platform isn't the model. The platform is the catalog of governed tool surfaces. SharePoint access, graph search, ticket creation, deployment status, whatever your organization needs. The moment you do this, your host applications become interchangeable at the tool boundary. Teams can build different experiences, Teams bots, web chat, IDE agents, without rebuilding the integration every time. That's the practical payoff of standardization. But it comes with one uncomfortable rule. You need an internal registry, even if it's informal at first. Not a public marketplace fantasy. An internal system that answers what MCP servers exist, who owns them, what version is deployed, what tools they expose, and what identity model they run under. If you can't answer those questions, your shared MCP ecosystem will become shadow IT with better marketing. So the workflow is simple and also relentless. Develop locally in VS Code. Use COPILOT for code, not for boundaries. Enforce contracts in CI, deploy behind identity and APM. Publish as inner source assets. And then, this is the part people hate. Operate them like real services, because MCP doesn't remove responsibility, it concentrates it. Limitations and risks, latency, overreach, and governance debt. Now for the part people treat like a disclaimer slide at the end: limitations, risks. The stuff that decides whether MCP becomes infrastructure or becomes another abandoned integration pattern with a nice logo. Start with latency, because agent systems are latency amplifiers. MCP doesn't create latency out of thin air. It exposes latency that was always there. Auth, network hops, backend variability, throttling, cold starts, and retries. The difference is that an LLM doesn't experience latency like a human does. A human waits, a model adapts, it tries another tool, it retries, it changes its plan mid-flight. And if your host is naive, it lets the loop keep spinning because the model is working. So latency isn't just a UX problem, it's a behavior shaping input. If you don't design around that, you train the system into conditional chaos. Slow tool calls lead to more tool calls, and more tool calls lead to more failures, and the system becomes noisy and expensive before it becomes useful. That's why you front-load SLOs and fail-closed behavior earlier. But here's the deeper limitation. MCP doesn't solve long-running work by itself. MCP can carry state in sessions, and it can stream, and frameworks can build on it. But your back-end reality still exists. Some enterprise actions take minutes, some take hours. And the model's default instinct is to keep the loop alive until it gets a result. That is not a safe default. So for long-running tasks, you need explicit patterns, async job submission, progress reporting, and durable orchestration that doesn't depend on one chat session staying alive. MCP can be part of that. MCP is not the whole thing. Next risk, overreach. MCP makes it easy to expose tools. That's the problem. When the cost of adding one more tool feels low, teams will expose internal capability surfaces that were never designed to be invoked by a probabilistic planner. Especially write tools, especially admin tools, especially anything that touches permissions. So the overreach failure mode looks like this. A team starts with safe, read-oriented tools. Then someone asks for convenience. Can we also create tickets? Can we also update list items? Can we also post to teams? Can we also invite guests? And each one is reasonable. Until you realize you've built an AI-driven control plane with no consistent approval model and no reliable attribution model. MCP didn't cause that. MCP made it scalable. So the architectural rule is simple. Expose read tools broadly, expose write tools narrowly, expose permission tools almost never. And when you do expose write tools, force explicit confirmations in the host and design idempotency so red trees don't duplicate damage. Now the one everyone wants to believe is handled already, prompt injection. MCP does not remove prompt injection risk, it relocates it. Instead of the model being tricked into outputting text it shouldn't, it gets tricked into selecting tools it shouldn't, or passing parameters it shouldn't, or fetching resources it shouldn't. The threat model shifts from what did the model say to what did the model do. So you design tool schemas to resist injection, you validate inputs, you constrain freeform fields, and you treat tool selection as a privileged operation that can require approval or policy checks. If you don't, you will eventually run a tool call that looked reasonable in the prompt, and you'll still be accountable for what it did. Now the enterprise class risks, data residency, logging, and auditability. Remote MCP servers are the obvious trap here. If your host forwards context to a remote server you don't control, you are exporting data. Not hypothetically, literally. And we didn't mean to send sensitive data is not a control. It's a post-incident quote. So you need explicit decisions about what context can leave the boundary, where your MCP servers run, and what telemetry is retained. In regulated environments, that means data residency constraints and retention policies for logs that contain tool parameters, document identifiers, and possibly content excerpts. Audit trails are not optional. They're the only reason enterprises will tolerate agentic systems at scale. If you can't reconstruct a tool call chain, who invoked, what tool, what parameters, what downstream API, what result, you have no defensible story when something goes wrong. And yes, it will go wrong. Finally, governance debt. MCP centralizes tool invocation. That sounds like control. It is also concentration of risk. A small number of MCP servers will become critical infrastructure inside the organization. Everyone will depend on them. And then those servers become the new shared service that accumulates exceptions, special cases, and temporary bypasses. Entropy doesn't disappear. It moves to the choke point. So treat MCP governance like you treat identity governance, ownership lifecycle, reviews, and deprecation discipline. If a tool exists, someone owns it. If no one owns it, it gets removed. If it can't be audited, it doesn't ship. If it can't fail closed, it's not production ready. That's the honest limitation section. MCP doesn't make AI safe. It creates a place where safety can actually be enforced, and that's only useful if you enforce it. MCP's maturity curve, spec evolution, remote registries, and agent discovery. So now that the risks are on the table, the next question is whether MCP is mature enough to bet on. And the only honest answer is, it depends what you think you're betting on. If you're betting on a stable enterprise-grade ecosystem of remote servers you can plug into production tomorrow, you're early. If you're betting on the core mechanics, typed tool calls, declared capabilities, and a host-mediated boundary, then you're not early. You're catching up to the inevitable. That distinction matters, because MCP has two maturity curves running at the same time. One curve is the protocol's core primitives. Tools, resources, prompts, lifecycle, capability negotiation, transport. Those are already useful today. They're the part that collapses custom glue code into a contract surface. The other curve is the ecosystem layer. Discovery, registries, trust, and how agents decide what to connect to without humans hand-wiring everything. That's where things are still moving. So separate what exists from what's emerging. What's real today is the boring part. The protocol is JSON RPC based. Servers advertise capabilities, hosts mediate the conversation and decide what context moves to what server. Transports exist for local and remote operation. In architectural terms, MCP already provides the minimum structure needed to turn tool use into a governable interface. That is the foundation. Now what's emerging is what turns MCP from integration standard into integration marketplace. Remote registries, agent discovery. The ability for a host or agent to say, I need a capability I don't currently have. Go find me a server that provides it. That sounds convenient. It is also where trust collapses if you're not careful, because discovery without governance is just automated supply chain risk. If the model can discover servers on demand, then the model can expand its tool surface on demand. And if that tool surface expansion isn't controlled by policy, you didn't build a boundary, you built a hole. So when people get excited about registries, the correct mental model is not App Store, it's Package Manager. And package managers have supply chain incidents for a living. So what does a mature registry model need to become enterprise usable? First, a trust story, not its open source. A real trust story. Who published the server? Who maintains it? What version is deployed? What identity and authorization model does it use? What data does it receive? Where does it run? What logs does it keep? And in Microsoft land, the trust story eventually collapses into Entra, because Entra is where identity becomes enforceable at scale. If a registry can't map servers to tenant identity, policy, and ownership, it's not an enterprise registry. It's a directory of things you shouldn't connect to. Second, a governance story. Even if discovery exists, enterprises don't allow install anything. They allow install from the approved catalog. That means you need approval workflows, environment promotion, and policy gates that sit outside the protocol. MCP is the protocol. The approval model is not. So expect a split. MCP standardizes the calls, and Microsoft governance tooling, Entra, APIM, Purview, whatever else will be used to control what gets connected. Third, a maturity story for agent discovery itself, because discovery isn't just finding a server. It's deciding whether the server's capabilities overlap with what you already have, whether the tool names are ambiguous, whether the schemas are safe, and whether the outcomes are predictable. Remember the earlier rule, overlapping tools create probabilistic behavior. Discovery increases overlap by default. So if you want agent-driven discovery in an enterprise, the real work is not how do we find more tools, it's how do we prevent tool collisions. That likely means standard naming taxonomies, server certification, and tool linting that catches generic or overlapping capabilities before they hit production. In other words, MCP will grow into the same governance shape as APIs did. Registries will exist, but enterprises will treat them like internal marketplaces with procurement rules, not like the open internet. And if you're listening to this as a Microsoft architect, the practical decision rule is simple. Build against the stable layer, contracts, and identity. Treat the ecosystem layer as optional. Use community servers for prototypes, demos, and learning. But for real tenants, you run your own MCP servers, or you consume vendor servers only when they come with enterprise-grade identity, auditing, and data residency guarantees. Because MCP's maturity curve doesn't reward optimism, it rewards boundary discipline. And if you anchor on contracts and identity today, the registry and discovery world can evolve later without forcing you to rewrite everything again. That's the only kind of future-proofing that works. Looking ahead in Microsoft land, speculation. Copilot Studio, Power Platform, D365. Now the part that needs a warning label. This is speculation, not because nobody has opinions, but because Microsoft product direction is a moving target and marketing names change faster than your tenant policies. So treat this as architectural trajectory, not roadmap promises. Start with the simplest observation. Microsoft is already building an agent ecosystem, whether you call it Copilot, Copilot Studio, or whatever got renamed last quarter. And the ecosystem problem is the same one MCP was created to solve. How does an agent safely discover and use tools across thousands of tenants and millions of workloads without every integration becoming bespoke glue? So if MCP keeps its momentum as an open protocol, the most likely future is that it becomes a common integration surface that sits underneath multiple Microsoft experiences, not replacing proprietary extensibility overnight, coexisting and quietly winning over time. Copilot Studio is the obvious pressure point. Copilot Studio lives in the world of connectors, actions, plugins, and custom agents. That world is powerful, but it is also highly platform-shaped. You build inside the Copilot ecosystem, you inherit its constraints, and you accept that portability is limited. MCP, in contrast, is portable by design. So the architectural question is not, will Copilot Studio support MCP? It's, will enterprises standardize their internal tool surface on MCP so that Copilot Studio becomes just one client? Because that's the move that changes the power dynamic. If the organization exposes SharePoint access, ticketing operations, inventory systems, and approvals through a governed MCP server layer, then Copilot Studio becomes a user experience layer. A good one, probably, but not the only one. And then you can swap clients without rebuilding the boundary. That's the end of custom glue in Microsoft terms. Now, Power Platform is where this gets uncomfortable because low-code and governance have a long, hostile history together. Low-code wants make it work. Governance wants prove it's allowed. So if MCP enters Power Platform, it won't be as a developer toy. It will be as an enforcement surface. Because the moment citizen developers can build agents that call tools, the organization needs deterministic boundaries, identity, policy, logging, throttling, and change control. Power Platform is excellent at scaling creation. It is not excellent at scaling restraint unless you enforce restraint by design. MCP provides a language for tool invocation that could let Power Platform consume enterprise tools without building yet another connector format and without forcing the model to guess API shapes. But the real value would be the governance alignment. The tools become centrally defined, centrally audited, and centrally versioned. That's the only way low-code agents don't become shadow IT with better UX. Now, Dynamics 365.D365 is the place where the agents can act story becomes politically real. Because D365 is money, leads, quotes, invoices, customer records, support cases. This is where a bad tool call is not an inconvenience. It's a business event. And D365 also has the most obvious permission complexity because it's full of role-based security models that were built for humans clicking forms, not for probabilistic systems issuing multi-step actions. So if MCP becomes the tool boundary for D365 actions, the identity model matters even more. OBIO becomes non-negotiable for user-driven actions because you need downstream enforcement that maps to a user. Managed identity becomes acceptable for controlled automation, but it has to be narrow and heavily audited. APIM becomes the expected wrapper because D365-oriented tool traffic will be bursty and expensive, and cost control becomes a first-class requirement. The likely Microsoft direction, if it happens, is that MCP becomes one of the standardized ways to expose actions and context across business systems, while Entra becomes the standardized way to issue authority for those actions, which is the same pattern Microsoft always ships. The protocol stabilizes the ecosystem. Identity stabilizes the risk. Everything else is product packaging. So if you're trying to interpret what this means over the next couple of years, here's the simplest prediction you can actually use. MCP adoption in Microsoft land will follow the path of every successful standard. First, it shows up in developer tools and side projects because that's where friction is loudest. Then it shows up in platform products as a compatibility layer. Then it becomes the thing you assume exists, and everyone forgets why it was controversial. But only if enterprises do the hard part. They build the tool boundary once, with discipline, and they refuse to let convenience erase intent. Because Microsoft will happily give you 100 ways to integrate. The platform always does. Your job is to choose one boundary model and enforce it until entropy gives up. MCP as AI infrastructure, the control plane for tool use. If you step back from all the mechanics, JSON RPC, schemas, transports, Entra flows, the real pattern shows up. MCP is not AI tooling, it's infrastructure. More specifically, it's the control plane for tool use. And that phrase matters because it reframes what you're actually building. You are not building a smarter assistant. You are building a system that decides what actions are even possible, under what authority, with what observability, and with what failure behavior. The model is the data plane. It generates proposals. It makes plans. It produces structured tool calls. But it doesn't own the permission boundary. It can't. It's probabilistic. It will optimize for completion unless you constrain it. So the host plus the MCP server layer becomes the control plane, the place where your intent gets compiled into enforceable capability. That's why this whole thing feels inevitable. Enterprises already know how to run control planes. They just weren't running one for LLM tool use yet. Now connect that to familiar constructs. People keep comparing MCP to an API gateway, and that comparison is useful as long as you don't oversimplify it. API gateways sit in front of backends and enforce things like authentication, rate limiting, and transformation. APIM does that. We already covered why it matters. But MCP adds a model-oriented contract surface on top of that. Tools and resources aren't just endpoints. They are capabilities shaped for a reasoning loop. They come with descriptions that influence selection, schemas that constrain behavior, and output shapes that allow deterministic downstream processing and auditing. So MCP isn't your gateway. It's the layer that makes your APIs legible to a probabilistic caller without letting that caller touch the raw edges. Then there's the service mesh comparison. Service meshes exist because microservices created too many sideways dependencies: identity drift, inconsistent retries, inconsistent telemetry, inconsistent policy. So the mesh moved those concerns into shared infrastructure: MTLS, retries, circuit breakers, observability. MCP is the same move, but for tool calls. Tool calls are just service calls with a different failure mode. The caller isn't a human or a deterministic client. The caller is a reasoning engine that can generate unexpected sequences and amplify its own mistakes. So you need the mesh-like controls, but oriented around tool invocation, identity binding, throttling, logging, input validation, and explicit failure semantics. And then there's the event-driven platform analogy, because not everything should be a synchronous tool call. A lot of enterprise work is inherently asynchronous. Start an export, kick off a compliance scan, provision an environment, run a workflow, wait for approval. If you force those into synchronous tool calls, you end up with timeouts, retries, duplicate actions, and an agent loop that keeps poking the system until something breaks. So the mature pattern is MCP handles the invocation contract, but long-running actions become asynchronous jobs behind it. Tool calls submit work, return a job ID, stream progress if appropriate, and require the host to handle completion without assuming the chat session is a durable workflow engine. That's where MCP integrates with actual cloud architecture instead of pretending chat is a scheduler. Now the hard truth, MCP doesn't make probabilistic systems safe. It makes them governable. Governable means you can enforce your assumptions at scale. Identity is explicit. Entra issues authority, and you select the flow that matches the scenario. OBO for user-delegated action, managed identity for operational tasks, service principles, and APIM for controlled multi-client exposure. Contracts are explicit, tools are named, scoped, and schematized. Ambiguity gets removed before it hits the model. Failure is explicit. You decide fail closed. You decide timeouts. You decide which tools can write. You decide what requires approval. And observability is explicit. You can build an audit trail that reconstructs what happened without relying on the model said it did X. That's what infrastructure actually does. It doesn't eliminate mistakes. It makes mistakes containable. So when someone asks, is MCP just another integration trend? The answer is simple. No. MCP is how enterprises stop letting probabilistic systems talk directly to deterministic systems without an enforcement layer in between. It's the control plane for tool use. And in Microsoft land, that's not a niche feature. That's how the platform survives the next decade of agents without turning into conditional chaos. Conclusion. Protocols don't make things easy. They make them governable. Most organizations want MCP to be a productivity feature, a faster way to bolt tools onto a model. That's the comfortable interpretation because it keeps the story in developer land. Better ergonomics, less glue code, more shipping. But that's not what makes MCP matter. MCP matters because it gives you a place to stop the model, a place to say you can reason all day, but you can't act unless the boundary allows it. And that boundary can be made explicit: contracts, identity, policy, logging, throttling, failure semantics. That distinction matters. Because in enterprise environments, the hard problem is not, can the model do this? The hard problem is, can the organization survive it doing this every day across every tenant, under audit, under incident pressure, under drift? Most integrations fail the same way over time. They start clean, then the first exception gets added, then the second, then the workaround becomes permanent, then the logs get ignored because they're noisy, then nobody knows which identity is actually doing the work. Then the system becomes probabilistic, not because the model is probabilistic, but because the boundary was never enforced as infrastructure. MCP is the attempt to reverse that, not by making models safer through wishful thinking, by making tool use governable through structure. So the key takeaway is one sentence, and it's not inspirational. MCP is a security boundary first. Developer ergonomics are the side effect. If you're building this in Microsoft land, you already have the ingredients most ecosystems don't. Entra gives you identity that can actually bind authority. OBO, when the user owns the action. Managed identity, when the workload owns the action. Service principles and APM, when you need an enforcement edge that can meter and throttle reality. Azure gives you a place to host the boundary as a real service, not a developer toy. And the governance stack, logging, auditing, policy, data residency controls already exists. But you still have to make the uncomfortable choice. You're not adopting MCP. You're defining where authority stops in your architecture. So here's the decision checklist that actually matters, and it's short. Who owns identity for each tool call? The user, the workload, or the platform? Where is authority enforced? In Entra scopes, in APM policies, in the server, in the host, or nowhere? What fails closed when things get weird? And what is observable enough that you can reconstruct a toolchain without trusting the model's story? If you can answer those, MCP becomes infrastructure. If you can't, MCP becomes another integration pattern that scales your chaos. If you want to see this implemented the way enterprises actually need it, go watch the next episode on building the Entra Obo flow and putting APM in front of your MCP server, so your agent tools become a governed surface you can defend.